Welcome viewers, in this video we'll see the Johnson counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. We know that we go to the topic Johnson counter. Counter is a digital device that is made up of flip-flop. Flip-flop is the storage element. It will store 1 bit of data. So this counter made up of flip-flop, there is a counting purpose. It will count from 0 to n or n to 1. This Johnson counter is very similar to the ring counter. The ring counter separate video available. Now we'll see what is the difference between the Johnson counter and ring counter. Ring counter means it is going in a ring format. 0 to n, again it goes to 0. Is similar to Johnson counter, also similar to ring counter, but some differences available. The Johnson counter is similar to the ring counter. The only difference between the Johnson counter and ring counter is that outcome of last flip-flop is passed to the first flip-flop as a input in the ring counter. Last flip-flop output is nothing but the input of the first flip-flop. But in Johnson counter, the inverted outcome Q0, Q bar of the last flip-flop is passed as the input. In ring counter, last flip-flop output Q is passed to the first flip-flop input, but here Q bar. Inverted output is passed to the first flip-flop. That is the one of the difference. The remaining work of the Johnson counter is same as that ring counter. The Johnson counter is also referred as the creeping counter. Right? Now we'll see the further details. In Johnson counter, the number of states equal to number of flip-flop. Here we are going to use the 4-bit Johnson counter. So we need 4 number of flip-flop. Below is the block diagram of 4-bit Johnson counter. Like ring counter, there are 4 D flip-flops are used in the 4-bit Johnson counter, and the same clock pulse is passed to the all inputs of the flip-flop. So here we are using 4-bit Johnson counter. 4 D flip-flops are used. Same clock pulse is given to all the 4 flip-flops. So it is coming under synchronous counter. This is a synchronous counter. Now we'll refer the logic diagram. So there are 4 D-type flip-flops available because of 4-bit. The nature of D flip-flop is the input what we are giving, that will be available as a output. D0 means Q also 0. D0 means Q also 0. D1 means Q also 1. That is the nature of D flip-flop. The input what we are applying is reflected in the next stage of the flip-flop, whatever may be the previous stage. So here what is the data we applied, the same thing will be available at the output. See this, it is like a serial in, serial out shift register. The data are serially passed. If the Q4 is connected to the first flip-flop, that is a ring counter, so that form the ring. But in Johnson counter, we are connecting Q bar, complemented input, inverted output of the 4th flip-flop is connected to the first flip-flop. That is the difference. If we connect Q4, it's a ring counter. Here Q4 bar is connected, so it is act as a Johnson counter. That is the only difference. Right. So this clock pulse is given to all the flip-flop. Now reset is available. Reset means it will reset the output as 0. Reset means 0. Right. All 4 flip-flop output becomes 0 when the reset is given. Now we'll see the operation. It has reset pin act as on and off switch, so that flip-flop. So it acts as a on and off switch. So it will reset the output. Clock pin is used to observe the changes in the output of the flip-flop. So every clock pulse, the output will changes. Now we'll see the truth table. Consider the truth table of 4-bit Johnson counter. The output of the preceding flip-flop is connected to the as the input of the next flip-flop. So we know that it is serially connected. Output of first flip-flop is connected to second. Second is connected to third. Third is connected to fourth. Fourth flip-flop complemented input is again connected to first flip-flop. That is the connection. So that it forms the ring. But here connected to inverted input. So that become a Johnson counter. The clock signal is used to know the changes. It contains 4 flip-flop. Q1, Q2, Q3, Q4 are the 4 outputs of the flip-flop. So based on that, we'll see the truth table. What is the truth table of this Johnson counter? The counter counts the states of cycle in a continuous closed loop. So initially all the values are 0. All the output of all the flip-flops are 0. Then the clock pulse 1 is passed. So the first flip-flop output is 1. Right? First flip-flop output is 1. Remainings are 0. In the next second cycle, what happened? The last flip-flop input is connected to the first flip-flop. Last flip-flop output is 0, but we are connecting inverted output. So the 0 become 1 and 1 is given to the first flip-flop. So the first flip-flop output is 1. This earlier available 1 is passed to the second flip-flop. It goes to second flip-flop. The data is passed. 1, 0, 0 is passed to the next. Right? Initially all are 0. While passing first clock pulse, the output of first flip-flop is 1. Remainings are 0. We know that inverted output of last flip-flop is connected to the first flip-flop. That is 0 means 1. So now the output of first flip-flop is 1. That is 0 inverted and 1. Earlier available output of first flip-flop is passed to the second. Second is passed to third. Third is passed to fourth. So now become 1, 1, 0, 0. Then in the third clock pulse, this 0 is passed to the first flip-flop. That is inverted. 0 inverted means 1. Now this 1 is passed to second flip-flop. This one is passed to third. This one is passed to fourth. So it become 1, 1, 1, 0. Then in the fourth clock pulse, this 0 is passed to the first flip-flop. Inverted. 0 means 1. 1 is passed to the first flip-flop. So the first flip-flop output is 1. Now this output is passed to second. This one passed to third flip-flop. This one passed to fourth flip-flop. Now see all are 1. In the fifth clock pulse, now this 1 is passed to the first flip-flop. 1 means inverted. Inverted means 0. Now becomes 0. Now this is passed to second flip-flop. This is passed to third. This one passed to fourth. Now becomes 0, 1, 1, 0. In the sixth clock pulse, this 0 is passed to the first. But 0 means inverted. 1 means inverted. 0. Now becomes 0. This 0 is passed to second flip-flop. This one passed to third flip-flop. This one passed to fourth flip-flop. Now becomes 0, 0, 1, 1. In the seventh clock pulse, this one is passed to the first flip-flop. That is 1 means inverted. Inverted means 0 is passed. Then these zeros are shifted. So it becomes 0, 0, 0, 1. Then in the 8th clock pulse, this one is passed to the first flip-flop. 1 means inverted. 1 means 0 is passed. Now these zeros are shifted. Now finally it becomes 0, 0, 0. Right? Start from 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 0. Then it becomes 0, 1, 1. Finally it becomes 0, 0. It's like a ring counter, but the output is in different format. Right? The last flip-flop output, inverted output is passed. 0 means 1. 0 means 1. 1 means 0. So that it is like a forming the ring with a different format. So that it is called a Johnson counter. So in this video we discussed the Johnson counter. Very similar to ring counter. Only the difference is inverted output of fourth clock pulse is fourth. Inverted output of fourth flip-flop is connected as the input of the first flip-flop. So that we are getting inverted input is applied. So based on that, the data are serially passed. So that we got initially 0, then 1, 0, 0, 1, 1, 0 like that. Finally we got 0, 0, 0. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.